this is the start of modern physics. So we are in the 19th century. People are making all kinds of new discoveries. And so we'll start at the first one. So we'll start at photoelectric effect, right? So where did that come from? So photoelectric effect was first discovered by Frank Hertz, who was experimenting on shooting light on different things. And he noticed that sparks occurred in air when exposed to ultraviolet light. But he couldn't explain a lot of things that he was seeing. And so we're going to talk about each of those things. So it was first discovered by Frank Hertz during experiments on E&M waves. And he saw that, well, he noticed that sparks happen more in air of his transmitter when he shone, exposed it to ultraviolet. That's a better word. UV light. So then he studied more and he discovered that when light is incident on certain metals, electrons are ejected from the surface. And these electrons are called photoelectrons. So there's many metal surfaces around you. Why are they not sparking? Why don't you see sparks coming out? If that statement is true. No, actually, it's the energy of them is not high enough to overcome the atmospheric conditions around us. So you need a vacuum for them to actually, so they are technically coming out. It's just that they're not being transmitted, right? So you can't see them because the atmosphere is so heavy that the interactions with the atmosphere causes them to stay where they are. They're not actually ejected out to where you can see them. So in order to see that, you have to create a vacuum in which they can travel. That's why you don't see the metal just sparking. Right? Okay, so this is the process that's happening. Light hitting a metal surface and electrons being ejected. Or lights of different kinds hitting the surface and electrons being ejected. So what do you notice about this picture here? There's red light, there's green light, and there's blue light, right? Oh, and that, remember I told you that some people like to write it as mu for frequency? I'm just going to change it to F because we're used to seeing F. So when red light is incident on it, what happens? Nothing. But when the same metal is exposed to like a green photon, a green light, we do see an electron being ejected. But what is the speed of that electron? About 3 times 10 to the 5 meters per second. And then when it's exposed to like a purpley blue light, the electrons are still emitted, but what's the difference? Its speed is More, right? It's 6 times 10 to the 5. So something is funny going on here. What do we remember about frequencies of red light and green light and blue light? Which is the highest frequency? Which travels the furthest? Did we remember having that conversation about why emergency signals are what color? Why are they red? Because they travel the longest. They have the longest wavelength. So that means they have the lowest energy. Blue light has the highest frequency, hence the highest energy. Now look at this picture again. And green is somewhere in the middle? Yeah.
Why does it having a longer wavelength means that it can travel?
It travels around bends more. So in atmospheric conditions. So if there's like fog or something, it'll travel around it.
Does it have longer wavelength?
Oh, well, okay, so look at it this way. This is not part of the thing, and I'll erase it later. So imagine there is a blockage here, and you send 2 lights through, one that has that wavelength, and one that has that frequency.
Oh, I see. Okay.
You get it?
Yep.
Which one will cross it? The red one, right? Has more probability of crossing it. So remember, this is how I remember it. Red turn signals, you can see it from furthest. So it has a long wavelength. So it can go around barriers, which also means it has the lowest energy. So red has the lowest frequency. Frequency is C over lambda. So frequency-wise, red is lowest. That means red has the lowest energy. Green has middle, and blue has most. So now look at this picture again. Do you see a correlation? What can you tell me? Low frequency light, medium frequency light, green, highest frequency light, blue, purple, whatever you may want to call it. They're close enough. So is the blue photon coming out, is that going to be the fastest? Will it have the highest kinetic energy? Will the green one be lower? And will it have lower kinetic energy? Excellent. Now, what about the red? There is no electron that's emitted. That's confusing. What they tried to do was they tried to increase the intensity, because that's what you would think, right? If you all that means is that intensity needs to be increased. So if I keep increasing the intensity of red, of course it should start emitting, right? But it didn't. Weird. And I'll show you how that is done. So if you go to this sim that's here, this is a simulation of this experiment. So can everybody click on that or just watch the board? It's either one. I think I can do this here, but if you guys want to do it, bring it up. Yeah, it takes a little time for it to upload, but it'll upload. And then you can play around with it.